In our lesson on enthalpy changes, we described heat of reaction as the amount of heat energy evolved or absorbed in chemical reactions carried out under standard conditions. However, since there are different types of chemical reactions, it means that there are also different types of heat changes in chemical reactions. Examples of these heat changes are heat of neutralization, heat of combustion, heat of formation, and heat of hydrogenation. In this lesson, we will focus on the heat of neutralization. In our lessons on acids, bases, and salts, we described neutralization as a reaction between acids and bases or alkalis to form salt and water only. Heat changes occur during this process. For example, if a dilute solution of hydrochloric acid is poured into a solution of sodium hydroxide in a beaker, and a thermometer is inserted to measure the temperature change, heat energy generated during the neutralization reaction will cause a rise in temperature, which can then be observed from the thermometer's reading. This shows that neutralization reaction is an example of an exothermic reaction. The heat energy evolved during this process is known as heat of neutralization or enthalpy of neutralization. So we can define the standard heat of neutralization as the amount of heat energy evolved when 1 mole of hydrogen ion formed from an acid and 1 mole of hydroxide ion from an alkali undergo neutralization reaction to form 1 mole of water under standard conditions. But the question is, how can the heat energy evolved during neutralization reaction be measured? This can be achieved by using a calorimeter. A calorimeter is a laboratory device which is used to measure heat changes during a physical or chemical change. It has a thermally insulated cover which prevents heat from escaping, and a container in which the neutralization reaction takes place. It also has a stirrer, which is used to stir the reaction mixture. The basic principle here is that the heat generated during the neutralization reaction in the calorimeter causes a change in temperature, which can be measured by inserting a thermometer in the reaction mixture. The heat of neutralization can then be calculated using the formula delta H of N is equal to mc times T2 minus T1. Here, delta H is the heat of neutralization. M is the mass of the reaction mixture, C is the specific heat capacity of the reaction mixture, and T2 minus T1 represents the change in temperature which occurred during the neutralization reaction. The summary of this lesson is, neutralization reaction is an example of an exothermic reaction. The standard heat of neutralization can be defined as the amount of heat energy evolved when 1 mole of hydrogen ions from an acid and 1 mole of hydroxide ions from an alkali undergo a neutralization reaction to form 1 mole of water under standard conditions. This is all we have for this lesson. I'll see you in the next class.